Hey everyone, it's Bradley Bush again with another algebra video for you. Today we're talking about even and odd functions. Kind of a cool topic. Here is the to-do list. First off, we'll talk about even and odd functions, what exactly they are. I'll give you a picture and explain so you have some understanding. Second thing, we'll talk about a single algebraic test that'll tell you if a function is even, odd, or neither of those two. And then we'll do 3 examples, one for each even, odd, or neither case. I'll also put in the video description timestamps of different parts of the video so you can skip ahead if you want. Even functions. So what exactly is an even function? So an even function has a specific type of symmetry, and that symmetry is symmetry about the y-axis. So if you have the y-axis right here, then the function, whatever happens to the right of the function, right of the y-axis, is mirrored perfectly, identically on the left side. So the y-axis represents a mirror, and whatever happens on the right of the y-axis is mirrored or replicated exactly on the left side. So that's an even function. If it exhibits y-axis symmetry, your function, then your function is an even function. How about odd functions? Well, odd functions will mirror each other, or mirror themselves, I should say, over the origin. So the origin is here at 0, 0. So what happens is, and I think this is kind of cool, I think this is one of my favorite parts of symmetry. If you have a point on a function in, say, quadrant 1, and that point is the point 1, 1, then the negative of that point, so if you take each of the elements and you take the opposite of the sign, which would give you a negative 1, negative 1, that point will also be on the curve, and you can join those two curves, those 2 points with a line that will pass through the origin. So this is a characteristic. It doesn't matter which point you pick. You could pick any point up here in quadrant 1, and you would be able to find the corresponding point in quadrant 3. This is quadrant 1, and this is quadrant 3, in case you're wondering. You'll be able to find the corresponding point in quadrant 3 that is the opposite sign, and you can join those 2 points with a line that passes through the origin. So this type of really cool symmetry through the origin defines an odd function. If your function has this type of symmetry, then your function is an odd function. Let's talk about the one test to rule them all. Sorry, I couldn't resist that. One test, 3 outcomes. So the test is actually pretty simple. All you do is you plug in a negative x instead of an x into your function. You simplify, and you see what you get out. And what you get out will tell you whether or not you have an even, odd, or neither of those two. So, pretty cool, huh? If you take a negative, let's look at the test for even functions. If you take a negative x and plug it into the function that you're given, and you get out exactly the same function as you had to begin with before you put the negative in, then you have an even function, which means you have symmetry about the y-axis, which can be seen here in the beautiful graph. If you put the negative in to the function and you get back the original function but multiplied by negative, so the negative of the original, then you have an odd function. If you don't get back either the function itself, which is in case 1, or the negative of the original function, which is case 2, then you know that you are in the neither category, and the thing that you have is neither an even nor odd function. Let's try these out. We have an example for each of these, so let's see how this works. So the question is the function x squared minus 4 even, odd, or neither? So we have our function down here. If I put in a negative instead of the x, and then we simplify, we can see what happens. And what does happen? Negative x quantity squared just gives us x squared, and the negative 4 stays the same. So what is that? Is that the exact same thing that we got back? It is, actually. That's the original function, right? Because the original function was x squared minus 4. That's exactly what we have, x squared minus 4. So we plugged in negative x, and we got back the original function. So this function we're dealing with, x squared minus 4, is an even function. Let's try another one. So our original function then now is x cubed minus x. So instead of having an input as an x, we're going to input a negative x. So that means we have a negative x here, and we have a negative x there. Now we just do some algebra. We simplify. Negative x cubed, negative times negative gives us a positive, and then times a negative again gives a negative. So we have negative quantity x cubed, and a negative, this negative distributed gives us a positive x. And we look at that and we're like, is that the same as the original? The original, again, was x cubed minus x, and the signs don't match up, but let's factor out a negative and see what we get. So if we factor out a negative, what do we have left? We have x cubed, and then we have a negative x there. And we look at that and we're like, hey, check that out. What is this right here? Well, that's the function itself, right? So we got back the negative of the function. So we plugged in the original equation, negative x, and we got back the negative of the function. So this is an odd function. Let's try one more. Our function that we're given is x squared plus 3x, and we're asked, is this function even, odd, or neither of those two? So again, the first thing we do is we take the function and we, instead of plugging in x, we plug in a negative x. So we have a negative here, and let's put in a negative here for this x. And now we just do some simplification. So negative x squared gives us x squared, and the negative and the 3 give us negative 3x. So we're done simplifying, and we look at it and we say, is this the same as the original? The x squared's the same, but then we have a negative down here, but we have a positive up here in the original. So it's not the same. So let's see if we factor out an x, if that changes anything. If we factor out an x, we get a negative x squared and a positive 3x. Is it the same now? Well, the 3x is now the same as the 3x, but now we have a negative x squared in our simplified one, but we don't have that in the original. So it's not, once we plugged in the negative x into the function, it was not the original, and it was not the negative of the original. So our function is neither even nor is it odd. Hopefully this video was helpful and gave you some background on even and odd functions and the test to determine if a function is even, odd, or neither of those two. If it was helpful, please subscribe to the channel, and thanks for watching. Have a great day.